The next larger topic that we want to talk about when we speak about soil formations is partly about how different materials are changing in the soil and also how they are taking place or changing their place in the soil. So, in this sense, we are going to be speaking about the different kinds of soil transformations. And this will include different types of like chemical weathering. What is included in all this then? So if we speak about chemical weathering, it will usually be meaning that different minerals are falling apart into different composing like ions and so on, and then be able to reconnect in different ways, or how they are going to become parts of like solubles, or like be able to be washed away by water as they become kind of a soluble matter. So this will be about oxidation and reduction, as we know, solution of like salts and so on. It can also be hydrolysis and hydration. Hydration and hydrolysis in order of as it appeared in my PPT. We can also have carbonation and complexation or chelation. I'll just put the letter one here. Chelation. Now, apart from soil transformations, we'll also be talking about then translocations. Translocations is, I think, a little bit more complicated to talk about. It will be about how these materials that went through some form of this transformation, so how are these going to, depending on the type of material, their size and so on, these grains, so how are they going to change their location in different soil horizons? And this will depend on various conditions, partly those conditions, environmental conditions like rainfall, precipitation in general, that actually relate to the chemical weathering processes as well. So this is quite complicated. When you are going to work with soils, if you ever do, these are just tiny little, like very basic points that we mentioned here, and I just want maybe later on that you are able to recall some of these main points that we're talking about, that yes, it's something that exists, and if you are doing research in the field, it will become much more complicated. So really, we're just looking at some of the very basic points, and then can say that transformations are not opposed to, but can be happening like at the same time as we have the translocation, so soil transformation, translocation. And here we said that there will be those that mainly include downward movement of materials. And we started with leaching. We also speak about the eluviation. We will have then putzolization and feralitization. There are slight differences in the spelling depending on what language you use, and the feralitization is sometimes referred to as feralization. You can write it with double L as well. Putzolization again as well can be spelled in different ways depending on American or British English you're using. Anyhow, these are just some of the main forms, and if we think about those that at least maybe include up and downward movement of materials, so those kinds of translocations would be then salinization, which is about salt, and also calcification, and glaying. Now the very important thing again that we need to say is that not only transformations and translocations can happen at the same time or are interlinked, but also that these processes will often happen at the same time. For example, glaying can come together with leaching with eluviation with putzolization, and so on. Usually we say that putzolization and fertilization would be opposite kinds of processes. They wouldn't really happen at the same time. Or salinization is very typical, as well as calcification to like drier areas, whereas leaching and eluviation would often happen in those places that are characterized by higher precipitation, as well as putzolization. So there can be slight differences, but often you would be able to identify more of these at the same time. And now I want to make a distinction really here between like leaching and eluviation and putzolization and fertilization in the first place. About glaying, I won't speak too much about now because it's really complex. It involves many processes of like the reduction and oxidization in different forms. So I will leave this out and it will not be in the exam. You don't need to explain glaying really in details. You just need to be able to identify that it has a specific like color, and often it will be tied together with leaching. So then in this video, let's have a look at leaching and eluviation in the first place. And I'm going to then put one on the left and the other on the right side of my little board because I want to show the main differences between them. Well, we need to somehow remember these names, and then perhaps it will be easier to speak about how or why they happen. So leaching and eluviation both happen in a place where there is high, like effective uh, precipitation. So rainfall exceeds evapotranspiration. Now that's why we had this kind of drawing in the PPT showing that the rain or the water, we have more coming in than going out. Of course there is evapotranspiration, but that is not that relevant compared to incoming rain, incoming water into our system. So precipitation will be the perhaps most important reason, and also we will have the various like organic acids. What does it mean? It comes really from the vegetation coverage that we have. That will be a reason for the development of organic acids that are able to, in the first place, do the leaching and washing out of these various materials like ions from the soil. So organic acids will cause acidification of the soil to some extent. Now, what we will experience in terms of like leaching, we have this kind of A horizon where we have the organic material really. So organic matter and so on, and this will cause the kind of acidification. So that's kind of a reason in the A horizon. And what we will find then below the A horizon is a B horizon, obviously. We will find a C horizon that is going to be kind of like untouched. And what is the specific thing about leaching is that we have a BW horizon, as they call it, and the W refers to weathering. So it's a really a weathered layer. I just put here weathered layer. That's why we have BW. And we have another name for this one. So soil scientists would call this as the cambic. And cambic comes from the Latin word cambiare, which is really changed. So that's simply the meaning of this cambic horizon, which really we find in the PPT as well, saying that the original material has been changed is simply went through weathering. Now, what do we not find? We don't find a layer where materials have been accumulated. What will happen in this case is that this weathered material really involves, and I'll just put this right here just to put it on my board, it will be downward movement or removal of soluble so whatever can be washed down or dissolved by water and washed away of ions. Mainly here we speak about ions. What this can mean, magnesium, potassium, also we can think here nitrogen and these kinds of things, but also oxides. So many different kinds of ions that can be dissolved by water. What will happen then is that this weathered material, this will lack some of these kinds of ions. And what can happen with these later on if they're not in the original like B horizon material is that they can be washed away. They are not going to be accumulating anywhere. They can later on, and exactly this little arrow can represent that they can be washed into the groundwater and maybe enter the subsurface water layers and so on. So if we think about leaching, it's something that is by nature a kind of soil forming or translocation in the soil, which is part of the soil development. But if we think about agriculture, this can mean that useful stuff, nutrients, so those kinds of materials that are valuable to plants can be simply trickling down, being washed away by the water. And also that if we use like fertilizers as well can be in form of these soluble materials be washed into water bodies. So that's why leaching can be something that we want to avoid, that can be troublesome to some extent. And that's why we said that, for example, the agricultural liming or burrow animals can be useful in this sense. Now, if we speak about illuviation, we had another name which is from French, the lessivage. Just to know about it, that this exists as well. And here again, we will exactly have the precipitation being more relevant than the evapotranspiration. So we think about the water coming in is more than the water going out. We'll also have a role here for the organic acids and acidification. So it's similar, but what will be different in a way is the kind of material that is involved. Here we're not speaking about the soluble ions that are going to be able to move, but instead we're speaking about the clay. So here again we have an A horizon. We will have some of these organic materials there. And what will be happening with the B horizon is that actually here we have an E horizon between the A and the actual B that we will speak about, and E is the illuviated there you go, illuviated E horizon, which means in this case that material will be basically lost and will be less rich in clay. So in this case, we're speaking about not those materials that are soluble, but those that are larger in a way, that are in a suspension, going to be able to travel downwards So in the suspension, things like clay minerals. So the E horizon that is on the top or under the A horizon directly, what we will see here is that basically it's richer in silt and sand and will less be rich in clay. Also, some of these iron oxide coatings will be missing. And so what we find then, and what is also important, this perhaps E is less colorful. The BT can contain perhaps more of organic materials. The BT horizon is what we also call the argillic horizon or argic. This will be richer in clay. And this we're talking here about alluviation. I just want to show the little difference in the possible pronunciation. This BT layer or horizon is where actually we will find the illuviation, ILL, happening, and that's where the clay will be kind of deposited or richer. So there's actually a new kind of horizon that is developing. It's not only, as we've seen here, there's a B which is weathered. It's not only that we have an E where something is missing, that is kind of empty of something, but also there is really a new horizon developing that is going to be called argillic, and that is going to be more rich in clay. What is also different is what is included in the process. So soluble ions mainly, in leaching what we speak about, and in alluviation we speak about mainly those that are in suspension. Not soluble, they are in suspension. And here basically what we need to mention is clay for the BT horizon, but also it can be things like organic materials like those that are found in the humus. So I think these are just some of the main points that we can highlight as we put these next to each other.